Figure it out. Stoichiometry is the relationship between the amount of reactants used and the amount of products formed in a reaction. That's all it is. Okay. Reactants used and the amount of products formed. And hopefully you realize one of them is going to run out, and that's when the reaction stops. Okay. All right. It's going to relate everything we did in the mole unit and what we did in chemical equations, because you have to be able to balance the chemical equation, because you can't do stoichiometry unless you have a balanced equation and you know what the products are. Okay. All right. So the balanced reaction gives us the ratio, and that's the word I'm going to use. They also have, in quotes, the recipe. I don't like that. All right. But that would be the equivalent of the sandwiches that we were making in that simulation. And the coefficients in the chemical reaction tell us the ratio between each reactant in the product, and the product, sorry. So 2 hydrogen molecules, okay, react with 1 oxygen molecule to make 2 water molecules. I don't like the second one, so I'm not going to write that. Scratch it out. The last one is the one we're going to use a lot. Nobody talks about molecules. I mean, this is molecules reacting. But if you're talking about molecules, you're also talking about what do we always use in chemistry? We don't use grams, we use moles. All right, because that's how you can relate to things. So this also says 2 moles of hydrogen gas in this case, react with 2 moles of 1 mole. Thank you. 1 mole of oxygen gas to make 2 moles of water. And then if you know the moles, you can figure out the grams. Okay? That makes sense? So if I say I need to have 10 grams of water formed, I can figure out how many moles that is, and then that'll tell me how many moles of hydrogen and oxygen I need to make that. All right? Okay, this is the same thing, but this is going to tweak how we're going to do the unit conversion. Not tweak it. How we're going to use these ratios in unit conversions. So we have 2 moles of H2, 1 mole of O2 goes to 2 moles of H2O. All right. Now you can use this balanced reaction to write ratios. Okay. So we know there are 2 moles of hydrogen for every 1 mole of oxygen, which means you can write 2 moles of H2 for every 1 mole of O2. So now you can see we're starting to build it into a ratio that gets written in those unit conversions that we did. Remember the unit conversions that look like this? That pen? Yep. 1 mole here, and then you have 10 grams per mole, and then blah, 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 blah. Now we're going to start to use stuff like this so we can predict how much we're going to get out of a chemical reaction. Okay? And there's also 2 moles of hydrogen, H2, for every how many moles of water? 2 moles of water right there. So then you can write 2 mole of H2 is 2 mole of water. And you can also flip those ratios, right? Just like we did in the other one. You can flip it depending on what you want, what you're trying to solve for. You can say there's 1 mole of O2 for 2 moles of H2, or 2 moles of water for 2 moles of H2, depending on what we need to do. Okay, are you ready to do a stoichiometry example? And then we'll pick this up tomorrow. All right, flip the page, please. Okay, so in chemistry, we don't use grams to compare molecules. Okay, we always use moles because there's different densities and all that kind of stuff. But moles is the constant. So we only use moles to compare one chemical to another in a reaction. So this, people love this term, the moles bridge. I don't love it, but I'll show it to you because a lot of teachers do. All the moles bridge says is that you can convert from the moles of one chemical to the moles of the other chemical. Okay. So between moles of chemical number 1 and chemical number 2. That's all the moles bridges. And you know how to do this. We're going to do some practice stuff, but you sort of know how to do this. You're using the reaction to do that. All right, here we go. Consider the reaction where nitrogen gas and hydrogen gas react to produce ammonia. So, what is nitrogen gas? What's the formula for nitrogen gas? N2. So this is where we have to use the last chapter. N2 gas plus hydrogen gas, H2, produces ammonia. What is ammonia? NH3. Ammonium is NH4. Be a gas, but is it a gas? I'm not sure. We'll just say it's gas. It's high temperature. Okay. All right. Now we have the reaction, but what do you have to do before you can do anything in the reaction? You have to balance it. Okay. If it's not balanced, you cannot do stoichiometry. So how do I balance this reaction? Okay. So we put a 2 in front of there. That's the nitrogen balance. Now, how many hydrogens do I have on the right-hand side, the products? I got 6. So I need to put a 3 in front of the H2. Now it's balanced. And now we can use it to do stoichiometry. All right. So this is what a stoichiometry question looks like. How many moles of N2 are required to react with 15 moles of H2? So remember in unit conversions, whatever you're given, yeah, I gotta do the math though. All right, so whatever you're given, you write down. What are you given? You've been given 15 moles of H2. 15 moles of H2. That's my starting point. Okay, then you look at the equation. Well, actually, I want moles of N2 is what I want, right? Moles of N2. And I need the moles of H2 to go away. So that means that has to be in the denominator, right? Because that will cancel that. So then you look at the equation. How many moles of N2 are in the equation per moles of H2? How many moles of N2? 1. How many moles of H2? 3. So this is 1 mole of N2 reacts with 3 moles of H2. 15 divided by 3 is 5 moles of N2. So if you have 15 moles of hydrogen gas, you need 5 moles of nitrogen gas to have this reaction work. Okay? All right. How many moles of NH3 are produced when 18 moles of H2 are reacted? So 18 moles of H2 is what you're given. And when I say 18 moles are reacted, like used up, you've used 18 moles. Okay? I want to know number of moles of NH3. So what's the molar, like what's the ratio of hydrogen gas and ammonia from the reaction? It's these numbers. 3 moles of H2 react to give 2 moles of ammonia. So that means 3 moles of H2. The reason you put it there is because you want the units to cancel. And it produces 2 moles of ammonia. Okay? The moles of H2 will cancel moles of H2. So then it's 18 times 2 is 36. 36 divided by 3 is 12 moles of NH3. Okay? Does that make sense? Right now, we're just doing single step stuff. So if you're given a certain amount, whatever these units are, so this is why in 2 units ago or whenever we did conversions, I always want you to write out what this is, because now, if you don't write it out, you're not going to know what the units are canceling. It's going to become even more important, especially when these become bigger. Okay? All right. What does it mean when you're told that another reactant is added in excess? What do you think that means? I can't. Sorry? It's more than what's required. All right. You just dump a whole bunch in. You'll have a ton of it left over at the end. Okay. But I like that. It's more than what is required. What is going on? Area. More than is required. You will have leftovers, basically. Okay. All right. That's the first step of stoichiometry. Okay, we're just converting. You're given a certain amount of moles at the beginning. You got a balanced reaction, predict how much you're going to get at the end. I would like you to do 1 and 2, please. Yeah. Numbers 1 and 2 on the next page. So this one and this one.